Hello friends, I am Sudeb Dasgupta, Professor in the Department of Electronics and Communication Engineering at IIT Roorkee. I will be offering a course on online certification program titled Semiconductor Devices for Next Generation Field-Effect-Transistor, which is basically more than more, through a physics perspective, which is run under NPTEL by the Ministry of Education, India. So let's have a look at the objective of the courses. The course will actually give you an understanding about the MOS device physics, which is probably the workhorse of electronic industry both in the digital domain as well as in the analog domain. We will be also looking at more than Moore era MOS devices, which basically means that with the downscaling of the devices, the various other factors coming into picture, what physical parameters needs to be seen, evaluated and checked for these devices to work properly in coming generation circuits. That's the second objective of the course. So in this we will be studying nanosheet FETs, Fox sheets, 2D materials. We will be also studying on CFETs, etc. Finally, studying devices individually will have no implication until and unless you do a circuit implication of that. So the third objective of this course is to have the circuit implementation of these devices, which we will be learning in the few lectures at the starting of our online certification program. And finally, we need to look into the optimization problem of each of these devices so that the circuit analysis which we do is proper and overall healthy output is available to you. So these are the basic 4 objectives of the course. Now, who will find this course useful? Well, the undergraduate and the postgraduate students in the domain of electronics and communication engineering and physics with semiconductor as their specialization will obviously find it useful for their academic programs as well as those who want to pursue their higher studies. This course will also be useful for practicing engineers of microelectronics industry who are working in the domain of devices. So the way the course has been fabricated is that even if you're uninitiated in this area, the course will help you to actually drive this course in a much better manner or learn the course in a much better manner, and it will be useful even for higher levels of learning, right? Now, what is the organization of the course? How the course is being built around? As I discussed with you in the previous part, there is no prerequisite for this course, which means that you need not have extensive initial knowledge for that. What you require is a basic understanding of physics and, of course, basic understanding of mathematics, which will be helpful for understanding this course. There are 12 weeks for this course, which is spread over 60 lectures, each with a duration of approximately 30 minutes. The course broadly includes a comprehensive understanding of VLSI technologies, starting from fundamental physics of semiconductor devices to advanced devices as CFETs, Fox sheet FETs, nanosheet FETs and their circuit applications. Initially, first few lectures will be on basic MOS devices and then finally ends up at 2D material used in semiconductor domain. So this whole course will give you a basic background and it will also help you to start your journey towards the semiconductor domain in general. Now, let me conclude this introductory discussion. During the course, assignments will be given to you and for solving and submitting these assignments, which will be evaluated at our end. At the end of the course, you will be evaluated by means of an examination, and those who are interested will also get a certificate about passing the course. There will be TAs who will be helping me in running the course. So any questions which you have regarding or queries and questions regarding the content of the course will be answered at certain points of time. You can also interact with us email and through other media platforms. I hope to meet you in the course and hope you will enjoy the learning throughout the lecture series. Thank you and happy learning.